laws of precession. In 1894, Swami Sri Yukteswar, a great Hindu sage, described our solar system and the Great Cycle.
We learn from Oriental astronomy that moons revolve around the planets, and planets turning on their axis revolve with their moons around the sun. The sun, with its planets and their moons, takes some star for its jewel and revolves around it in about 24,000 years of our Earth, a celestial phenomenon which causes the backward movement of the equinoctial points around the zodiac.
The theory, the binary, is that our sun is rotating around another sun. And that, of course, the whole thing, the system, what you might say, is also rotating around what they call the grand central sun.
Could it be that the ancient knowledge of this dual sun was lost during our descent into the dark ages of the Kali Yuga, just as we lost our knowledge of a heliocentric system? And as we now ascend toward the golden age once more, will science rediscover this binary companion? As we look deeper into the universe and expand our knowledge of its motion, we've come to realize that single suns are more the exception than the rule.
Roughly half of the stars you find in the universe are alone, and the other half are in groups, and often the groups consist of two, and if that is a group of two, then we talk about binary stars. But it can also be 3, 4, 5, there's no limit on that.
Binaries, that it seems to be the common observation in the cosmos now. Most of them are actually binary systems.
With so many binaries in the heavens, why wouldn't our sun have a partner? Then again, if it did, wouldn't we be able to see it by now, with our high-tech observatories or the Hubble Space Telescope? While there might not be a visible companion, it doesn't mean one's not there. Some stars can't be seen at all, such as black holes or old neutron stars, and others, like brown dwarfs, are barely detectable. Also, the long orbit period of 24,000 years will make the connection of our sun to a binary partner extremely difficult to detect. One sign we'd expect to see would be the changes in the sun's rate of movement. In a binary system, orbital speed is not constant, and theorists say it would cause changes in the precession rate.
As soon as two celestial bodies orbit each other, according to Kepler's laws, you have elliptical orbits. And if you have that, you have where when the bodies are closer to each other, they tend to be faster, and then as the other object moves further away, it gets slower and in again.
If the current rate of speed were constant, a complete binary cycle would take almost 26,000 years. But scientists have confirmed that the rate of precession is increasing. In a binary system, this would mean that two stars are moving closer together, and the cycle would take much less than 26,000 years.
Analysis of the data has shown that it is actually closer to a 24,000 year period. If we keep observing, if we make future measurements, that would indicate certainly that we are in a binary system.
The cycle of a binary system might also be observed in the geological record. Mathematician Milutin Milankovitch noticed the Earth has had global warming and cooling cycles that roughly correlate to the length of the great year. Just as the binary model answers questions of the past, it could also be applied to solve scientific questions of the present. For example, at the edge of our solar system is a field of asteroids known as the Kuiper Belt. In 2001, a team of scientists from the University of Michigan made a startling discovery. The asteroids appear to end very abruptly. A sheer edge like this would be expected in a binary system. Also, a large number of long-cycle comets in our solar system come from a very small part of the sky. Although some astronomers like John Matisse and Daniel Whitmire think it may result from the gravitational pull of an unconfirmed 10th planet, our Sun's binary could also have this effect. Another enigma. All celestial bodies have angular momentum, a force that corresponds to their mass and motion. Yet in our solar system, angular momentum is unevenly distributed. The Sun has 99.9% of the total mass